Here we go with our first notes, our first video notes in our marine biology class on marine ecology. So some of the advantages of this hopefully will be, like I said in class, that it'll free up some more time at class to do things that are more exciting than taking notes, because nobody really likes taking notes, and also allow you to kind of work at your own pace, go back and watch things. If you missed my description, or you don't have to worry about writing frantically to try to keep up with me, things like that, you can pause and do what you got to do. So you probably, I would recommend just listening to what I say and then maybe pause and write down once I'm done before I flip it to the next slide or something like that, just to kind of keep yourself, so you're kind of not multitasking, just listening to me, paying attention, and then worrying about writing down so you can kind of see what I'm referring to. Another advantage being also if you're absent, you can easily catch up on the notes and kind of hear what I'm saying instead of just having to rely on copying down somebody's notes and not really knowing what everything you're writing down means. So anyway, here we go with our notes on the ecological concepts that we've been talking about in class. First of all, the basic definition of ecology is the study of interactions between organisms in the living and non-living parts of the environment. So now might be a good time to pause and write. And then the abiotic versus biotic factors, which we've talked about in class. Living being the biotic factors, like bio being life. Non-living, abiotic, add a in front of a word means without. So the living things that you might be looking at, obviously the fish that are swimming around the ocean. The phytoplankton is a big deal. It's kind of the base of the food chain. Coral, it's a living organism. Bacteria, which are often overlooked. Some of the abiotic factors that we might be thinking about, sunlight or solar radiation, light energy, obviously the temperature of the water, the currents and how they transport stuff around the world. Nutrients could be another thing, we don't have that on there. Tides, and they're a similar thing to currents. Sediments, or the sand, or the substrate, right? Things where critters might be trying to build a home or find a home, or sediment or sand being things that could be decreasing water clarity, which could be another thing that you could add to your list. So there's a lot of abiotic factors that affect life, and of course they all affect each other. Like in class we talked about how if there's a lot of sediment in the water, that's going to reduce water clarity, which is going to impact sunlight and could even impact other things as well. A really, really important thing, and this kind of gets at it, is that everything is interconnected, right? We have sediment affecting water, things like that, or the amount of phytoplankton. Phytoplankton disappears, that's going to affect fish, which is going to affect other things, right? Food chains, food webs, everything is interconnected. Changes affect lots of other organisms. If something disappears or something increases in number, that's going to affect something else. Really, really big deal. Trophic levels, something that's we'll be talking about a lot. Look at food chains and food webs. The trophic level is just an organism's place in the path of energy flow. So is it a low trophic level? Right? Is it low down here, trophic level 1, where it's a primary producer, or is it something higher up where it's in the middle of the flow of energy, or is it at the really, really top? The lowest trophic levels are always the largest, right? Because you have to support all the organisms above, and we talked about this in the class, only about 10% of a level's energy is passed to the next level, 10%, so not very much. So this is why you're always going to end up with this pyramid shape, right? Because only 10% of energy is going up. And the trophic levels that we looked at, I'm not going to have you write them down because they're here, but do take note of them. Make sure you know primary producers. These guys are the photosynthetic organisms, the phytoplankton. These guys are creating energy for everything else. Then you have the consumers, and these guys are anything that's eating something else. So the primary consumers, you get two primaries, primary producer, primary consumer, usually zooplankton, little critters eating the little phytoplankton, and they get eaten by bigger things, the secondary consumers, bigger things, the tertiary consumers, or you can just say third consumers, that's fine. If you really go up to the fourth level, it's called quaternary or quaternary, but it doesn't really matter, you can just call that fourth level, or the top level is also called the apex predators. So you can also use that terminology as well, apex. Those are the top guys. Food chains versus food webs. A food chain is a path of energy flow through a chain of organisms as it applies. So this guy over here would be a food chain. So we're always going to start with energy from the sun. Not always in a food chain, but obviously that's where it starts, to our producer, to our consumer. Right? There's specific examples. The arrow, this is really important, the arrow always points in the direction of energy flow. So in this case, energy is flowing from the sun to the producer, so that's the way the arrow is going. Right? It's going from the producer to the consumer. Arrow is going up. A food web, pretty much the same thing. It's just all of the food chains in an ecosystem, or at least a great number of food chains in the ecosystem. So in this food web here, you got energy from the sun going to diatoms, which are a type of phytoplankton, which could go to these guys, which could go to these guys, which go here, everywhere. They can get pretty complex. All right. It's kind of interesting to note that organisms can occupy different trophic levels depending on what they're eating and what's eating them. Right? So while this lanternfish could be a primary, he could be a primary producer, primary consumer, secondary consumer if he goes in that food chain. If you went this way, and this guy eating this guy, and this guy, and this guy, and then that would increase his trophic level to a third order consumer. So depending on what food chain they're part of, they could actually occupy different trophic levels. But this is going to show all of them. And like we said in class, the one thing that never really seems to get shown in these food webs, right, what's going to return energy from the top down to the bottom are those decomposers, right? Releasing the energy that's stored in a body, freeing it up for nutrients, turning it back into nutrients for these guys down here at the bottom of the food chain. And like we also said in class, things that maybe eat dead stuff. So if you're a scavenger and you're going to turn that into poo, and then that's going to be nutrients for these guys later on too. And then finally, some of the interactions you would see in a food web or in an ecosystem. Obviously, you have the predator and prey interaction, so things eating and things being eaten and all that. You've got competition, right? Things going after the same resource. So maybe you've got multiple items looking for the same food, whether it be phytoplankton or a specific kind of fish or whatever. And they also have symbiosis, or things working together, relying on each other. And there's a couple different types of symbioses. The first one would be parasitism, when one organism depends on another to survive. Often it harms the host, not always. Some parasites are smart and they realize, hey, wait a minute, I'm living off this guy, I want to keep him alive. Other times, if it's something that's easy to move on, so like this lamprey here is living off this fish, and once that fish dies or becomes unhealthy, it's pretty easy for the lamprey to find another fish. He's living off this fish, he's living off the hog, this guy, not so good, harming him, he's probably going to die. The other type of symbiosis would be commensalism, right? When one organism benefits and the other is unaffected. Right? Example of this would be barnacles on turtles or whales or something big, right? These are barnacles, little guys, little crusty things growing on this whale. These guys are getting transported around, they get a nice hard substrate to live on. Does the whale really care that it has barnacles on its face? No, it's a huge whale. They don't really impact how fast he swims. Doesn't really matter that much. And then the last kind would be mutualism, where both organisms benefit. A good example of that would be coral and the zooxanthellae, which are the little photosynthetic organisms that live inside them. The zooxanthellae, they do photosynthesis, and they make sugars and things like that, which they pay to the coral. They give to the coral kind of as rent. The coral is the structure for them to live in. So the coral gets some food, zooxanthellae gets a house, everybody benefits. Another classic example is this guy over here. This little fish called a cleaning wrasse. He's eating the crud in this guy's teeth. He's getting a free meal. This guy's getting the crud taken out of his teeth, bacteria, parasites, things like that. So everybody's happy. So those are some of the different interactions that you could see in an ecosystem. With that, we are done with our first set of video notes.